Okay, let's talk about the unit conversions problem set. Number one, you got 154 bikes, so you write that down as a fraction first. Then the next fraction is going to be the conversion, right? And we're going to kilobikes. We know that. Bikes to kilobikes is like a single thing into 1,000 things. So I put bikes on the bottom. There's 1,000 bikes in 1 kilobike. That's because kilo means 1,000. And that's it. If I cross cancel the units, then I'm left with kilobikes, which is what I want. Doing the division, I get 0.154. And in this solution set, we're not going to do sig figs because this was assigned before we talked about sig figs. So 0.154 kilobikes. Okay, number two. We got this speed skater. They're going a certain distance in a certain amount of time, and we want to convert it. Let's see, we've got 1,000 meters, and we want to know how many megameters that was. All right, well, that's meters into megameters, so I can do this in one step as well. Mega means 10 to the 6, or a million. A lot of you mistook mega for milli, but mega is a million. So when you cross cancel, get 1,000 at 10 to the 6. It's 10 to the 3 over 10 to the 6. That's 10 to the negative 3 megameters. That makes sense. Less than 1 megameter is 1,000 meters. Number 3, we've got this tiny thing, 5 micrograms, the Carifractus cinctus. So I start with 5 micrograms. I want to convert it into grams. That's also one step. Micrograms into grams. Micro means something. Micro means 10 to the negative 6, or a millionth. Cross cancel my units, and I'm left with 5 times 10 to the negative 6, or 0.000005. Okay, here's me messing up the auto shape. Let's see if I can draw a rectangle this time. Good. Number 4. All right, we've got these 30-kilometer-an-hour whales. We want their speed in miles per hour. So I start with 30 kilometers an hour. The only thing I'm converting is the kilometers to miles. I'm leaving the hours the same. We're told at 1.6 kilometers per mile. Cross-cancel the kilometers. And I've just got 30 divided by 1.6. which works out to be about 18.75. On to the second part of this problem. What's this speed in miles per hour? You could do this in a couple of, or meters per second, excuse me. Do this in a couple different ways. You could start with the 30 kilometers per hour and go to meters per second, or you could start with the 18.75 miles per hour. Your choice. I'm going to go kilometers per hour. So I'm going to convert the kilometers to meters first. That's 1,000. And then I still have to convert the hours to seconds, and recall that it's 3,600 seconds per hour. The hours cancel, the kilometers cancel. Now you multiply through. You have 30,000 on top and 3,600 on the bottom. That gives you about 8.3 meters per second. Okay. Now the hardest problem, at least part B is the hardest problem. We have water. It has a density of 1 gram per centimeter cubed. What is that in kilograms per centimeter cubed? Like the earlier problems, we're just changing one unit, the gram, to kilograms. So there's 1,000. We cross-cancel the grams. That's just 1 over 1,000, right? So it's 0.001, or 1 times 10 to the negative 3 kilograms per centimeter cubed. Part B is tricky. Part B, what is this in milligrams per meter cubed? The reason it's tricky is centimeters cubed and meters cubed is a cubed unit. So I start with 1 gram per centimeter cubed again. And I can convert the grams to milligrams first. That's easy enough, 1,000 to 1. Here's the tricky part. I know that there's 100 centimeters in every meter, so I can convert. Whoops, gotta put centimeters on top. I can convert that 100 to 1, but I have to cube it because it's centimeters cubed and meters cubed. I'm doing it 3 times, multiplying it each time. So it's 100 cubed, not just 100. This leads to a pretty big number. 1,000 from the milligram to gram conversion and 100 cubed for the other conversion, which is 1 billion, 10 to the 9 milligrams per centimeter cubed, per meter cubed.